Okay, guys. So today these are the topics. If you will see in my screen, we will go. I will start with the introduction of SD-WAN and how Cisco Viptela merged with basically and Cisco and how Cisco and Viptela merged and they have basically created one SD-WAN solution. We will discuss the traditional router architecture and what are the different planes we are having on this particular traditional router. Then we will discuss the SD-WAN component, where we will discuss vManage controller, vSmart controller, vBond controller. We will discuss the data plane as well, where we will discuss V is routers and C is routers. And after that, we will see how we can host or where we can deploy these particular controllers, right? Then I will also explain you the overlay network and your underlay network. What's that? And after that, we will also see what is your programmatic APIs, which is also supported by your SD-WAN solution, or what is your vAnalytics, right? So we will see these are the 12 topics which I am gonna cover in your today's session, guys. Now, so what I will do, I will basically start the thing. I will start explaining from your router and its different planes in networking. Okay. So if you will see here, I have I have written here basically, I have taken few images. Guys, I'm not looking on a chat right now. So I will take your questions after the class. Let me just go with the flow. Okay. So if you will see, guys, these are the Cisco routers. Okay. Now, in these routers, basically what we have, let's suppose these are the two routers. So let me just go like that. This is one router and this is second router. Both the routers, they have a connectivity. So let's say this data interface is connected by this particular router data interface directly. Let's say this is F0x0 interface, and here also let's say you are having F0x0 interface. Here you have IP address 10.1.1.1 and here you have IP address 10.1.1.2. Apart from that, let's suppose you do have this particular interface. Let's suppose this is your console port. You do have this particular interface as well. Let's say this is your management port of your router. On this management port, let's say you have enabled SHS and telnet. Means you can able to do the telnet and you can able to do the SHS on this particular router. Now, let's suppose what is the requirement here? What I want. Let's suppose I want to configure these particular IP address on this router, and I want to configure this IP address on this router, and after that I want to enable the OSPF. What I want to enable the OSPF basically. And let's take an example. I do have one PC here which is connected with one of the port here, and I do have one more PC here. Let's say connected with this port. This is PC2. This is PC1. Now this PC is on your 10.10.10.0/24 network, and this PC is on 10.10.20.0/24 network. Here we have IP address 1.1, and let's suppose on this enter we have IP address .2, and here also .2. Let's suppose this F0/1 and this is also F0/1. Simple design, guys. We have two routers. These two routers have a direct connection, and we want to configure the OSPF now. Now, if you want to configure the OSPF, what you will do? What is the first start? You will basically log in on this router. What you will do for login purpose? Either you will use telnet, either you will do the SHS, either you will basically connect the console cable. So these are the options you are having, right? After successful login on this router, basically what you will do? You will basically start configuration, right? So you will run these commands like interface F0x0, right? You will put here IP address 10.1.1.1/24, right? Then you will put here no set. So like that, you will start the configuration. In similar way, you will also configure your another interface, which is F0Y1, where you will configure the IP which is 10.10.10. maybe 2/24. And after that, you will basically run the routing protocol. So you will type here router OSPF, maybe 100. Then after that, you will put here network. Then you will define the network. Then you will define the area. All these things you have to do. Okay, cool. So let's suppose you have done this configuration on this router. Let's say this is R1 and you did the configuration on this router, which is R2. So guys, when you are doing any kind of configuration while logging into this particular router, when you will take the telnet, SHS or console, which means what you will do, you are accessing the management plane of your router. What? You are accessing the management plane of your router. Now, when you will run this particular OSPF, right? You will run the OSPF on R1 and you will run the OSPF on R2. So what they will do? Now they will start the OSPF negotiation. Now they will basically send some OSPF messages here and there, and they will advertise their routes and everything, right? With each other. So what they will do now? So this particular traffic of your OSPF, it is basically handled by the control plane. This traffic is handled by the control plane. And in your router, to handle the control plane traffic, we have a something called route processor. What? We have a route processor, which is also known as RP. What this route processor used to do? It used to basically, so when this router, he will advertise this particular subnet towards R1. What it will send? It will send in a SLA, right? Now, these particular SLA is processed by the route processor, and what it will basically maintain your SLA database, or I can say it will maintain your routing information base. In case of EIGRP, what it will basically maintain your topology table. All such kind of calculation it will do, right? When he receive these SLA, it will run the SPF algorithm, right? Shortest path first. SPF algorithm it will run, right? It will try to get the best path, right? All these things this particular router will do. And all these tasks is done by the control plane. Let's suppose you are using authentication for your OSP, then all these authentication will also take care by your control plane of your router. And after that, from this routing information base, basically what your router will build, it will build your forwarding information base, which is also known as your routing table, the active routing table, and your ceph table. These tables it will build because if this PC1 wants to send any data to PC2, what will happen? That PC will forward the traffic here. Now this traffic basically received on F0Y1 interface, and after that your packet is checked against the routing table, right? It will check for this destination 10.10.20.1 where it is. So that information he will get from your FIP table or your ceph table, guys. And now because your routing table or ceph table is basically we are using for forwarding the actual data of your users, which means this is the data plane basically of your router. So in your router, how many planes we are having? We have a management plane, we have a control plane, and we have a data plane, guys. Now, if I will explain you the advanced architecture of these particular routers, so let me just show you here. If you will see these ports basically, These ports is your part of your data plane. Just remember. And all these ports basically they have connected internally. Maybe here they've connected internally something called, we have a one thing which is known as switch fabric. What all these data ports, they have a connectivity with the through your switch fabric with the route processor or your control plane of your router. So your all your protocol processing, everything is done by the control plane, or we can say your route processor. Let's suppose when we receive the LSA in case of OSPF, or when we receive the topology information in case of your EIGRP, all these type of database, all the calculation, your all the algorithm, your control plane will run basically. And what it will do after running these algorithm, it will give that information to your data plane in a form of your FIP table, forwarding information base, or in a form of your routing table. And from this routing table, what they will build the CEF table. So they will use your routing table and CEF table for transferring the data, or basically it will handle your users data. So in your router, just remember guys, we have a three planes. We have a management plane, we have a data plane, and we have a control plane guys. If let's see if I'll show you one more diagram here. So these are the some internal component of your control plane guys, where you have a CPU, right? And this is your switch fabric guys, and this is comes under your data plane basically. Okay, I'm not going in depth basically of that architecture. If you want to see the forwarding, how they will do the forwarding, they will basically get the routing information and everything from here, right? And after that they will do the data forwarding basically. That's how they have a connectivity with each other. So you can see forwarding plane is your data plane, and this is your control plane basically. And if you want to see the architecture of your route processor, then route processor architecture looks like this. Route processor, where you have a multi-core CPU, you have a memory as well. And guys, just remember one thing, in your Palo Alto device, sorry, in your routers, basically, they have all these shared memories. So they will share your CPU resources and your memory resources with the control plane and data plane. They don't have a dedicated resources, basically, just remember. Okay, they don't have a dedicated resources. No. So this is the architecture of your routers, and it has just a three plane. Now, let me just explain you in a very, very small diagram, because maybe it looks like a complex for you. So let's suppose I have here router R1. I have here router R2. I have here router R3. This is the setup right now I'm having. I have a connectivity of these three routers like this: F0Y0, F0Y0 here, F0Y1, and F0Y0 here. Let's suppose here I'm using 10.1.1.0/24 series, and here I'm using 10.1.2.0/24 series. IP address is .1 here, .2 here, .1 here, and .2 here. And I have this particular PC here, PC1, and I have this particular PC to here. This is F0Y1 and this is F0Y1. Here let's say I'm using 10.10.10.0/24 network. IP is 1 and 2 here. Here let's say I'm using 10.10.20.0/24. Now, and here I have .1 and here I have .2. Now, if you will basically see on this interface, basically Or let's take example of this interface. If this router, let's suppose, wants to update any type of routing information, and let's suppose we are running OSPF here. We are running OSPF here as well. So which means on this particular port F0Y0, what type of packet we will receive? What type of packet generally we will receive on this particular port, right? Either we can receive a routing packets, or either we can receive a routed packet, guys. Anyone know what is the difference between routing packets and routed packets? If you know, you can write on a chat. So what is basically routing packets, guys? Okay, I got lots of good answer from Deepak, from Suraj, from Sajid. Okay, guys, I think you know. Cool. Now, let me just tell you here. So, your routing packets basically what? They will include the traffic. This routing packets, they will, let's suppose, when this router R3, he will update this particular network 10.10.20.0 information to R2. And after that, this R2, he wants to further update the information to R1 regarding this particular prefix. And when you receive such kind of packets, these packets is known as a routing packet. So if I'll say your OSPF packets, your EIGRP packets, I'm not writing like what are the packets they will send, your BGP packets, your HSRP, VRRP packets, basically all these packets, they basically are known as routing packets, and your routing packets is always handled by the control plane, guys. In control plane, which component it handle? The component is your route processor. What component name is route processor? So basically your routing packets are the routes updates from the protocols. Basically, what is routed packet? Let's suppose this PC, he has sent one packet, he has initiated ping to 10.10.10.2, which means now this ping reaches to R3, then R3 forward to R2, then R2 will forward to R1. Now when R1 receive this request on this interface, this packet is known as routed packet, and your routed packet is handled by the data plane. Now, in your data plane, what we have a majorly two things. We have a routing table, which is also known as your forwarding information base, which is FIB table, and we have a CEF table, guys. So all these management of your routing table and your CEF table, forwarding of your routed packets is a task of your data plane. And your control plane, what it will do? It will basically responsible for managing the routing updates. Basically, it will handle all your routing packets. Okay. Now, if I'll say one more thing, let me just give you one example. Let's suppose I'm having here one SNMP server. This is my SNMP server, and I have a somehow connectivity of this SNMP server with this router. Now, if this SNMP server wants to pull any information from this router, which basically plane of that router will basically handle this particular request? Which plane of this router will handle this request, guys? Can you just write on a chat? That's great, guys. I'm getting lots of good answer. Varun, so you're wrong. It will not handle by the control plane. It will handle your management plane, guys. So majorly your SNMP, your telnet, your SHS, your HTTP, your HTTPS, all these particular requests is handled by this particular management plane of your network. Okay, cool. So I think this is clear, guys. What is the management plane of your router? What is the data plane of your router, or what is the control plane of your router? I think this thing is clear to everybody, guys. I hope this is clear to everyone, guys. Write on a chat. Okay, cool. So now what we will do, now let's discuss the same thing with regards to your, or let me just tell you one more thing here basically, because see, in your control plane, basically, if I'll tell you your packets, which is your, if I'll take example of your STP packets, your ARP packet, your RIP protocol packet, your OSPF packet, your DSCP packet, your EIGRP packet, your BGP packet, all these type of packet is always processed by the route processor in your, basically in your router. Just remember. Now let me just give you the same thing with regards to the SD-WAN now. So let's suppose, guys, we have a management plane here, we have a control plane here, and we have a data plane here. Now let's suppose, I'm just taking some hypothetical number, guys. Okay, let's suppose on this router I'm having total, let's say I'm having around 40 core of CPUs on this particular R1 router, and I'm having, let's suppose, around 16 GB of RAM. These are the typical resources I'm having in this particular R1 router. So let's suppose out of these 48 cores, let's suppose around 8 core of your CPU is utilized by the management plane traffic, and let's suppose it is also utilizing around 4 GB of your RAM. Now your control plane, let's suppose around 20 CPU or 20 core of your CPU is utilized by the control plane, and because it will process your control information, which means it needs RAM as well. So let's suppose around 6 GB RAM is utilized by the control plane of your router. And now we have a data plane here. Let's suppose remaining around 20 core of your CPU we are having for data plane, and we are having around 6 GB of RAM for your data plane, right? So if you will see, guys, in this example, around your 50% resources is utilized by the management plane and your control plane, right? And remaining 50% resources of your router is basically utilized for by the data plane. Now, guys, let's suppose you have here so many users. You have lots of users here, and all these users, they are communicating with servers here. Maybe you are having here servers, which means for handling the actual traffic, because guys, this is your business traffic, right? If these people, they will communicate with these server, which means it will basically generate some revenue to your organization. And for that, you will see you just have a 50% of resources. So which means, let's suppose if you have around 2000 routers, I'm talking about the WAN routers, guys. Okay, do not confused here. Let's suppose you have around 2000 routers, which means around 100 routers performance. I'm talking about on the basis of numbers, 100 or 1000 routers performance you just need for management plane and just for the control plane traffic, right? Now, let's consider. So guys, what SD-WAN has offered, what they have done, let's suppose what we can do, if we can remove the management plane from this router, or we can remove the control plane from this particular router, which means if we remove the control plane and management plane from this router, which means now whatever resources we are having on this router, all resources we can utilize for the data plane, right? So whatever resources we are having, these resources we can utilize for your data plane traffic. So guys, the major idea of your SD-WAN solution is that what SD-WAN has done, what they have created some centralized solution. Basically what they have created, the centralized management. They have created some centralized management, means they have removed the management plane from these routers. Let's suppose you have a lots of routers. They have removed the management plane from these routers and they have put, let's suppose, into this device. That device is called, according to the SD-WAN solution, is known as vManage device. SD-WAN has also removed the control plane functionalities, and they have basically, let's suppose, they have put here where there is a one new component of your SD-WAN is your vSmart. They have removed the management plane and control plane, and all these routers, they have a connectivity with these particular controllers, which means now, because now they have separated the management plane of your device and the your control plane of your device. For control plane, they have introduced the vSmart, and for management plane, they have basically introduced the vManage. This will handle your management plane. Now they have a connectivity, which means all type of management. If you want to configure, let's suppose, OSPF between these routers, or you want to configure the IP address like these things, you can able to do it from here. Now you don't need to connect with the console cable. You don't need to do the telnet or SHS, nothing. You don't need to log in into all the devices. If you want, even though you can able to configure all the devices at the same time from this particular manager, which means we have basically created a dedicated management plane on one device, and who will basically take care of all the management plane related activities of all these devices. Here I have 3. Let's say you have 1,000, or you have 2,000, or 4,000, or 6,000, doesn't matter. It can able to handle up to 12,000 devices in your fabric, guys. Which means it can able to process the 12,000 devices. It can able to manage the 12,000 devices in your SD-WAN fabric. And we have introduced the vSmart device here. What it will do now? Let's take an example, guys. See, previously what they are doing, they are sending the OSPF, LSA updates with each other, right? But what they have done, they have introduced one more device, which is known as vSmart. All the routes, let's suppose this particular R1 router, he is having these two subnets. What he will do, he will basically send these routing information to vSmart. This router, he will also send the routing information to vSmart. This router will also send the routing information to vSmart. Let's suppose you have here 10,000 routers. All these 10,000 routers, they will send the routing information to vSmart. Now all the calculation, basically it will run the your algorithms, basically as whatever algorithm is used by the OSP, like shortest path, first, discast, all these kind of routing algorithm is run by this particular device, which is vSmart device. Now we will get rid of this control plane things as well from these routers. And what it will do, it will basically like this control plane, what he used to provide the routing table, or I can say your forwarding information base, right? Fifth table to the data plane. This vSmart device will also do. After generating the fib information, it will basically advertise the routing information towards these devices. So all the control plane activities now is done by this particular device. So guys, this is the, we can say this is how your SD-WAN technology evolved basically. This is how your SD-WAN technology evolved. They have think for this solution because guys, see, if I'll say the very complex environment, here we just have a very small environment, right? Maybe if I'll take example, very complex environment where you are receiving here 10,000 routes, or maybe you are receiving here 1 lakh of routes, which means now it's become very hard for this router. Your control plane needs to do lots of calculations and all, right? So for these type of calculation, now we have dedicated put one basically device who will do all of them for us, which is known as vSmart, guys. So this is how, so if I say your management plane of your router is replaced by the vManage controller of your SD-WAN. Control plane of your router is replaced by the vSmart basically. And your data plane is only available on these particular routers. Only they have a data plane basically. So all the resources, because they are having these shared resources, they can utilize these resources for processing the user's request. This is the one benefit you will get. Apart from that, there is a one more benefit you will get, guys. Let's suppose in the same design, we have here vSmart. I'm just writing here vSmart, guys. And now let me just introduce few more routers. I have here, this is my internet fabric, let's suppose. And here I have few more routers, maybe R4. I have here R5. And let's suppose I'm having here R6. Behind these routers, I'm running some LAN network, maybe LAN 1. Here I'm having LAN 2. And I'm having here LAN 3. Now, these routers, they also have a connectivity like this, let's suppose. Now, let's take an example here. Let's suppose in this situation, let's suppose if these people who is sitting behind these LANs, if they wants to communicate securely, let's say with this PC or with this PC over the internet, what will happen? What was the solution offered by the WAN technology? We can go with the DMVPN here. Now guys, see the things in DMVPN, as I have also discussed yesterday, they have to go through with the phase 1 exchange and your phase 2 exchange of your IPsec VPN, right? They have to go through with the phase 1 and phase 2 exchange process. All these routers, let's suppose now if you have a 10,000 router, or let's suppose 1,000 router, which means this R1 router needs to maintain the 1,000 IPsec tunnels. If you have a dual ISP, in that case, this router needs to maintain the 2,000 IPsec tunnels. Which means when they will do the exchange of phase 1 and phase 2, these particular thing. So you in your phase 1 and phase 2 exchange, your router, there's a one process called crypto process. What this crypto process? This crypto process basically do the calculation of your keys, which is known as Diffie-Hellman keys, right? If you are aware of the VPN, then they have to do the calculation for ASCII ID, the session keys and all, right? If somebody has attended my VPN classes, there I have to explain all these details and all these things in a detail, like ASCII ID D, then they have created ASCII ID A, then they have created ASCII ID E, right? Lots of calculation they have to do. After that, they will start the phase 2 action where they will do the same type of calculations, right? And finally, they have generated the encryption key and they have generated the hashing key, right? This is the final, and these two keys they will use for encrypting the data which is flowing between this PC and this PC. Now guys, your phase 1 and phase 2 exchange is also removed with the help of DMVPN. What they just said, you don't need to do any type of phase 1 and phase 2 exchange. You can directly share the key with vSmart. You can directly share this encryption key and hashing key directly with vSmart. So all these devices, they will send the key with this particular vSmart, and vSmart update regarding the keys to the other peer. So they are directly getting these keys now. So this particular challenge is also taken care by the SD-WAN solution. You don't need to do single configuration for VPN because your IPsec is by default enabled in your SD-WAN technology. It is by default enabled, guys. So you don't need to do single line configuration for that. So this is how basically your SD-WAN evaluation happens. Cool. Now let me just explain you the high level overview of this particular picture. Now let me just tell you the SD-WAN components. I have already explained here, but let me just go through with this picture here. So let me just decrease the size. I hope guys this particular image is visible properly. Just say yes or no on the chat. I'll take your questions guys after the session. Okay, cool. Everyone able to read the things, right? Oh, okay, good. I got the for lots of yes, which means everyone able to see it. Now, if you will see in this particular picture, so your management plane is your vManage. This is the one of the controller of your SD-WAN, which is vManage controller, who will take care of the management activities, guys. We have here vSmart. This vSmart controller will take care of the control plane activities, guys. I will not touch vAnalytics for now, guys. Now, this vManage is provide you the graphical user interface for doing any kind of configuration. Even though you can also do the automation, it will take the Python. You can do the Python automation, Python scripting. If you are good, you can do the automation using Python. If you have any kind of third-party tools, you can also use these tools for doing the automation. You can automate lots of activities of your vManage. So we have a vManage. We have a which is take care of your management plane. We have a control plane which is take care by the vSmart controllers, and we have a data plane which is basically where you have a actual your branches, your campus, your data center, and your cloud edge routers. Basically, these are the vEdge routers. These routers will basically process your actual data. These controllers you can put anywhere. Maybe the best way you can put on the cloud. You can put these control on the cloud. These are the actual devices who will basically handle the traffic. And if you will see here, these are the transport guys. These are your band technology, MPLS, internet, 4G and 5G guys. And all these particular edge routers what they will basically create a control connection with vManage, with vSmart, with vBond. So guys, I will come into this vBond in a while. So vBond is known as a orchestration plane basically, or I can say in simple word, it is a authenticator. It is an authenticator or validator. What it will validate this particular router belongs to your organization or not. It will just do the validation of these routers is belongs to your organization or not. Okay, so these are the generally high level overview. So we have a management. So guys, now in SD-WAN, if I'll discuss in your SD-WAN, how many planes we are having? So we have a management plane, we have a control plane, we have a data plane, and we have a orchestration plane. So in your SD-WAN, it has introduced majorly 4 planes basically. Now we will discuss one by one what are these devices, how we can use them, all these things we will discuss. And these are the guys building blocks, or these are the main SD-WAN components. If you know these components, you are good with the SD-WAN technology, guys. Now, I do have one more picture here. Same picture. We have a vBond, which is your orchestration plane. We have your vManager, which is your management plane. We have a control plane. These are your vSmart. These are your transport, guys. So if somebody else, what is transport? You can say transport is the WAN network basically. So we have an internet as a, we can use internet as a transport, MPLS as a transport, 4G as a transport basically. We have your WAN edge routers. They are available at your data center, campus, branches, home networks and all, guys. This is your data plane. Here we have a physical devices or virtual devices. Now just remember one more thing, guys. All your controllers, which is your vBond, your vManager and vSmart, all these are the virtual appliances. They are the virtual appliances. We don't have any kind of physical device for them. These are the virtual appliances, basically. Just remember, they are the virtual appliances. Now, I'll move into my topology. So guys, if you see in my topology, this is the second topology of my lab, guys. This is for doing some advanced practicals. If you will see here, I have around 3 vManager who will take care of the management plane of these particular vanish devices. These are the vanish routers basically. So these routers management plane activities is taken care by this one. This is your vSmart controllers. I have a 3 vSmart controllers. What they will do, they will take care of the control plane of these particular vanish devices. And these are the vBond. So I have here 3 vBond on my topology for the redundancy purpose. Okay. So generally this topology I have designed for doing your TLOC extension lab, your VRRP lab, your service chaining lab. So that's why I have put here firewall device, right? And I have put here multiple controllers for doing your redundancy related labs, basically. Okay, cool. Now, let me go here. Let's move towards the next thing, which is now let's basically discuss what is vBond controller basically. What is your vBond controller? So let me just decrease the size of this image little bit because size is increased a lot. Cool. I hope guys my screen is visible to everyone properly. Just say yes. Okay, I got lots of yes, which means we are good to go. Okay, cool. So We have discussed what is the traditional router. All these things I have written the theory information as well here, guys. So if you want to refer later, you can able to refer it. Cool. Now SD-WAN component. So your Cisco Viptela SD-WAN solution is made up of 4 segregated planes. Basically, first plane is known as your orchestration plane, and in orchestration plane we have a one device is known as vBond. We have a management plane. In management plane, we have a vManage controllers. Then we have a control plane where we have a vSmart controller. And we have a data plane where we have a WAN vEdge devices, guys, and your cEdge devices. If you will see vEdge devices, which means they are the Viptela, guys. vEdge, it's not virtual edge, it's a Viptela edge devices, guys. These are the Viptela routers, we can say. If you will see cEdge, which means these are the Cisco routers, basically, who supports the SD-WAN functionality. These are the Cisco routers. C means Cisco, V means Viptela, guys. And also, if you will see this V here in vManage, it's V not related to your virtual. It's a Viptela managed controller. Viptela smart controller. Viptela bond controller. Okay, it's a vBond controller. So it is stand for Viptela, guys. This V is stand for Viptela. Do not confuse with that. Now, so if I'll discuss the what your vManage controller will do, it will basically take care of the management plane. What it manage all the WAN edge devices, or we manage all the WAN edge devices from this vManager, which means what type of management we have to do. So let me go back here. So I will start with the management plane first, and vOne plane I will discuss later, guys. So what it will do, your vManager, it will provide you the single pane of glass for managing your day 0, day 1, day 2 operations, which means what it will do, this is the single pane of glass from where we can do the management. What type of management we can do? So your management includes, let's suppose on this particular vManager, you want to configure the IP address on these interfaces. Let's suppose you want to enable the OSPF routing protocol here. You want to enable any type of protocol here. All these things basically we will do from the vManage controller, basically. And it is just a single pane of glass for management purpose. Even though you don't need to log in into this device, guys. If your device is joined the fabric, if this device is a part of your fabric, which means now if you want, you can do the SHS as well on this device from here. You can check the health of this particular device from vManage dashboard. It will provide you the dashboard, basically, or the graphical user interface where all the network engineers, they will interact on the daily basis for doing their daily basis changes. If you want to do some kind of troubleshooting as well on this device, you can able to do it from here. If you want to see what is the jitter on this interface, what is the packet count on this interface, what is the top application, what is the top talkers or top traffic is going through this interface, you can able to see everything from here. So such kind of management you will get through this particular vManager controller, guys. It's a single pane of glass. Now just see the traditional architecture, guys. In traditional, if you want to manage anything here, you have to check the things on each and every routers, right? But with the help of this, you can check everything. If there is any problem with any of the transport, like if your any of the ISP is not working, behaving well, you can able to also check these things basically through this particular vManage. If you, let's suppose this particular router is not able to communicate with this router, what in the traditional way, what you have to do, you have to log in into this router, then you have to initiate a ping, right? But this time you can able to do the same thing from here. You can able to generate the traffic. You can able to generate the traffic from here, and you can check the connectivity. Which connectivity is your traffic going through MPLS, or is your traffic going through internet? Is your traffic is going through both the links? You can able to see both the things, guys. So such kind of management capabilities you will get. Apart from this, you will get the configuration capabilities. Whatever configuration you want to do in this device, you can do it. If you want to, let me just give you one simple example. Let's suppose you have introduced one new SNMP server in your environment. Now you have to add the details of this SNMP server. You have to configure this SNMP server into all your WAN devices. Let's suppose you have 10,000 devices. What do you have to do? If you will do these jobs manually, what do you have to do? You have to log in into each and every device, and you have to do it. Maybe it will take around 5 to 6 days to complete this particular task. But with the help of this vManager, you can able to achieve just in 2 minutes. Let's suppose you want to upgrade your 10,000 WAN edge routers with the new patch. Let's suppose you have received there is a new patch where some type of bug you are facing into your devices. Now that bug fix is there on this patch. If you will basically install this patch manually on all these devices, it's become a tedious task. But with the help of vManager controller, you can do it in just a one click. So such kind of management capabilities you will get by using the vManage device basically. How vManage do the configuration? So your vManage, it will use the protocol is known as netconf. It will use this netconf protocol for pushing the configuration into all your WAN edge devices. How this netconf works and everything we will discuss in some other class, guys. How these peoples basically, they will sense the health of these devices. How my vMan is able to see everything, because what it will do, it will use the SNMP protocol. We can basically, what it will fetch the health of these devices, your interface health and everything with the help of SNMP polling. We can also able to SHS on any of devices because SHS service is there. With the help of SHS, we can SHS from vManage into all these devices, right? So these are the main management protocol, which is basically which is used by the vManager to basically manage your vManage devices. Cool. Now let me come here. Centralized provisioning, which means, let's suppose you can do the provision of all your vManage devices from one location. Let's say these are the WAN devices you are having. These are your WAN routers. You can able to provision all the configuration, everything from just one device. So you will get the centralized provisioning option as well. Your vManage is available on a multi-tenant mode or single tenant mode, guys. What do you understand with the multi-tenant and single tenant, guys? Anyone know? Can you write on a chat if you know what is multi-tenant, what is single tenant? Okay, cool, not an issue. Let me just tell you. So let's suppose if you want to basically deploy this particular vManager, what options you are having? Either you can deploy in your on-prem network. In your on-prem network, when you deploy this particular vManager, which means you will deploy either on EXI environment, on over the EXI server, or either you will deploy on your KVM server. Like you are having Red Hat OpenStack, you can able to deploy. For EXI deployment, you have to download the OVA image. of your vManage from the Cisco download portal, and for KBM you have to download the QCOW2 image. Now, when you deploy this particular device on-prem in your environment, which means this is the single tenant basically. If you have any type of public cloud, let's say you are using AWS, you are using Azure, you are using GCP. So if you are deploying your vManage into these cloud platforms, these public cloud platforms, this is also a single tenant deployment, because single tenant means this particular vManager is only dedicated for your organization. Let's suppose you are for abc.com, which means this particular vManager is only for abc.com. Now, there is a one more option you can opt from Cisco. What you can take the service from Cisco, which means you can deploy your controllers on Cisco environment as well, on Cisco cloud, guys. Which means now if you will deploy your vManager on Cisco cloud, that time Cisco have offers two solutions: single tenant or a multi-tenant. Which means multi-tenant means, let's suppose you just have around 10 devices, very small network, right? In that case, why you will basically go with the single tenant? Because single tenant, if you will go, you have to pay some cost. But you can get the multi-tenant, which means this particular vManage is shared by multiple companies. But so it's a simple thing, right? In your router, when we used to create the VRFs, right? So we are dividing one physical hardware into multiple logical routers. Like in your Palo Alto, we used to create a virtual systems. So we are, and in your Cisco, we can able to create the context, right? Which means one physical box, we will basically divide into multiple logical boxes like C1, C2, C3, and we can allocate these context to the different company. This is known as a multi-tenant. So Cisco has offered both things, single tenant or multi-tenant. If you have a lots of sites, if you have a very big organized, big network, you can go with the single tenant, guys. And around 90% customers, basically, they will opt this particular service if I'll say the deployment option of your SD-WAN controllers, everyone go with the Cisco cloud only. In a backend, guys, Cisco have uses the AWS environment, but the management of these controllers is now Cisco headache. If you want to basically increase the resources, let's suppose you have 1,000 sites right now. Now you have decided to open 200 more sites, which means now your device count will increase. If your device count will increase, which means now you need more resources on your vManage. So if you want to scale the resources, that's why always recommended, do not go with the on-prem deployment, guys. Either you can go with the public cloud deployment, either you can use the Cisco cloud deployment basically. And 90% customers, they are using the Cisco cloud, guys, for vManage or for your SD-WAN controllers. Okay, cool. Now, so from this vManager, it is also used for your sending the policies and your templates. Templates is your configuration scripts basically. It templates includes the configuration scripts. You can able to do the troubleshooting and monitoring. You can able to monitor the entire fabric from this particular single device basically. You can do the software upgrades. You can also get the GUI of this particular device. So you can able to, it will provide you two things. Either you can access it by a graphical user interface. If you want, you can also able to access by a CLI. Both options will be there. If you are good with the programming, then you can also do the things with the help of REST APIs. So three interfaces it will provide to the network admins basically. Programming interface will support REST APIs and your netconf APIs. It is highly resilience. Resilience means what we have to do. Somebody have also asked on a chat why we have a multiple vManager on my topology. Because guys, see, we are managing entire infrastructure from this particular single device. If this one device goes down due to any reason, what will happen in that case? I will lose the management capabilities of my entire SD-WAN fabric, or my entire WAN management is disconnected now. So that's why always recommended you can go back at least 2 or 3 basically vManager. So if one vManager goes down, you have another one who can basically take care of the things at that time. So we will always deploy these devices on a HA, or HA is not a good word here, I can say in a cluster. And this supports active type of cluster, guys. Okay. So that's why I'm having here. So highly resilience means we have to deploy these control in such a way so they are always available, guys. Cool. These are the main characteristics of your vManage. Now let's go here. Cisco vManage is the management plane of your SD-WAN system. It runs the user interface of the system, and it is the dashboard, and it will also provide you the dashboard where user or administrator interacts on the daily basis. It is also used to create device templates, which is your configuration. Like you want to enable OSPF, you want to configure static route, you want to configure WANer, all type of configuration. You have to do it with the help of template. This is the CLI scripts, guys. It will push the configuration. It will also perform the overlay traffic engineer, which means if you want to do the traffic engineers, what type of traffic engineers you can do it. Let's suppose in this diagram, I have these two networks, right? What I want, if my traffic from this router wants to go to this London router, what it will do, it will always go through the MPLS link. It will always follow this particular path. And I have another requirement. If my traffic is initiated by this router towards this router, it will always go through the internet. Then it will follow this path. Such kind of traffic engineering you can achieve from the vManager. So all these configuration you have to do from the vManager device. Let's say you have a requirement. If these peoples, they want to go to the internet, which means all this traffic will go to your internet cloud, then it will go to your head office network. Here your scrubbing will happen, then your traffic go towards the internet. So if you want to achieve such kind of traffic engineer, you want to just define the path for your traffic. In that case also you have to, all this configuration we will do from the vManager controller, guys. This part we have already discussed. It's a single pane of glass for managing whole WAN infrastructure. Centralized provisioning of the WAN edges, centralized template management, and centralized policy management, guys. Your policies we use for the traffic engineers, and your templates we use for configuring your routing protocols, your WANer, all these details. It will also provide you the one centralized dashboard for the troubleshooting, centralized dashboard for monitoring. We can take the SHS access of any vManage from the vManage. We don't need to log in separately. Centralized software upgrade and downgrade. It provides the programming interface using API and Netcom, so we can automate using the Python scripts as well. It provides graphical user interface and CLI access as well. Now, guys, see this. We can manage around 2000 vManage devices using just one vManage. So let's suppose you have around 4000 WAN routers. In that case, what people is recommended, or what Cisco is recommended, you need 2 vManage. Okay, let's suppose if you have around 12,000 WAN is routers. In that case, you need around 6 vManage, because one vManage is only able to manage around 2000 devices. And guys, on a cluster as well, this is the maximum limit of your cluster. You can only able to put 6 vManage in a cluster, guys. And vManage is a virtual appliance, means it is available only on VM basically. So two images type, we have a like, when we download the images of your vManager from the Cisco portal, you will get the OVA image for EXI environment, and you will get the QCOW2 image for KVM environment. We can deploy vManager on your EXI environment, OpenStack, Azure, AWS, and GCP cloud platforms. Just guys, see this line. Your vManager is a significantly resource intensive, and most of the customer go with the cloud options because your vManager or this controller is the resource intensive controller. Even though guys, when I will run this particular control on my lab, it needs minimum 16 GB of RAM. One controller only, vManage. Other control like vSmart, vEdge, they will take very less, like 2 GB of RAM, but vManager take lots of RAM. Sometimes we can also take the Cisco managed cloud for vManage deployment, guys, and other controller hosting. So we can host these controllers on a Cisco cloud. This is also a recommended way, guys. So this is all about your vManage controller, guys. Now, let me just discuss regarding the next controller, which is your vSmart controller. vSmart controller basically facilitate your control plane activities in your fabric, basically. So, vSmart offers the control plane functionalities. vSmart controller are the brain of your overlay fabric, guys. Why it is brain? Because it is handling the control plane. All the routing updates it will send. Now, guys, let me just tell you one thing here. I will not go in depth for that for now, guys. These vSmart basically, what they will do, how these particular routers, your vanish routers, how they will basically send the routing updates, how they will basically exchange the information with each other, guys. So they will exchange that information with each other with the help of, there is a one protocol is known as overlay management protocol. They will basically create the OMP peering, guys. Overlay management protocol or OMP protocol is similar to your BGP protocol, guys. It is almost similar to BGP protocol. So in your SD-WAN fabric, overlay management protocol runs, guys. If somebody asks in your interview, you can just simply tell your vSmart and all your V edges or WAN edges, they will basically create the OMP peering with the vSmart, and they will exchange the routing information, your crypto keys information, everything as a OMP updates, guys. Okay. vSmart control a brain of the your overlay fabric. Now it's a virtual appliance. We can spin on AWS, Azure, Cisco, and EXI environment. So guys, for vSmart, it is also virtual appliance we are having. It supports active cluster, guys. What? It will support the active cluster basically, means, which means if you have here 3 vSmarts, they all are active basically. Anyone can send the updates to these particular vanish routers if there is any change on the routing. Okay. It distributes the control plane information, which includes your routing or your routes or prefix information and your crypto keys. What is these routes information? So guys, if I'll say here, if you will see this thing, so if you will see these subnets, these are the LAN subnets, right? Our main focus of this particular SD-WAN solution is to basically advertise these subnets. So what they will do, this WAN as router, what it will update these subnets to your vSmart. This router will not update the subnet directly here. No, all these routers, they will just update the routes information to vSmart. Now it's a job of vSmart to further update the routing information, which means your India vNAS device, it will update these routes information to to your vSmart. Now vSmart basically update this particular routes to your Dubai router and your London vNAS routers. Similar thing, if these Dubai routers, they will update this particular subnet details to vSmart. And now vSmart will update these details to your head office vNAS router and your London office vNAS routers. How they will update? They will use the overlay management protocol for that, OMP protocol. Okay, cool. Now, it distributes the data plane and control plane policies, guys. What is the policies? So let me just connect my charger. Okay, cool. So it distributes the data plane and control plane policies to the WAN as routers, which means if you want to do the traffic engineering, guys. So let me go here as well. Let me decrease the size a little bit. Okay, cool. So what it will do? It will basically distribute your control plane policies. Basically, what do you mean by the policy? Let's suppose there's a one requirement you have in this topology. What do you want? You want all your traffic from these devices. Let's suppose if anyone from this network wants to communicate with this network, what you want? That traffic will not go directly to this one. I don't want this. What I want if they wants to communicate with this, that traffic first go to your head office, then it will come back, and after it will go here. Means let's suppose I want hub and spoke kind of environment here. Means all my branch office are the spoke, and I have a head office as a hub network. Means all the traffic from these branch office, they will send to the head office, and now head office will further distribute the traffic. If you want such kind of things, by default, what happens? By default, basically they will create a full mesh topology. Full mesh means this router will create a IPsec tunnel with this one. This will create IPsec here. Means full. Each routers will create IPsec tunnel from each transport. This is the default behavior, and they can communicate directly with each other. But if you want to change this default behavior, how you will change? You will only able to change with the help of these control policies. So who will take care of that part? Your vSmart, your control plane. It is the device who will take care of all these things. It creates the OMP peering with VS devices, and it will distribute the routing information. It is also known as a BGP route reflector or DMBPN NHRP routers. What is this BGP route reflector? What is the concept of route reflector, guys? So in BGP route reflector, what used to happen? Let's suppose we have this setup like this. Or let me just go in here as well. So if I have this topology, so guys, when is, it will send these routes details to my vSmart. It will not by default send these routing information to any of these devices. It will not send. We have to basically do the configuration, which means all your WAN devices, they will basically send the routing information to your vSmart. That's why it's become the route reflector. And now this device, he will further send the routing details basically. Okay. Now, let's see what is the next point I am having. DTLS tunnels formed between vSmart and vBond and vManage and vManage's device. So guys, this point I will discuss when we discuss your control plane in details. Okay. But just remember guys, one thing, according to this topology, just remember your vManage and your vSmart, your vManage and your vBond, your vSmart and your vBond, they will create a tunnel with each other for sending the data securely. Your WAN is routers basically. They will create a tunnel with vSmart, with vManage, with vBond. What type of tunnel? It is your TLS or DTLS tunnel. It's just if I'll say in a simple word, it is your SSL tunnel. They will create a DTLS tunnel. DTLS is a by default tunnel. What is the difference between TLS and DTLS, guys? Anyone know? Can you just write on a chat? What is the difference between TLS and DTLS? So your TLS is based on TCP and your DTLS is based on UDP. And by default, they will create a DTLS tunnel for communicating securely with each other, because you know this traffic, when your vSmart, they will communicate with your WAN device. Your traffic is also going through the internet and your these public internet cloud and all, right? Anyone can see the information if you will not encrypt the traffic. So they will create these tunnels, TLS and DT. Don't worry, we will discuss this thing in some other class, because I have to discuss so many things on that, how they will create a tunnel, right? So many things are there, guys. Okay, cool. Now let me just go here. Let me just see something. So I think you will get the everything here. What it will do, it facilitate the fabric discovery, which means what it will do, it is the device who will basically update the routes to all your WAN edges. When it will update the routes to WAN edges, which means each WAN edge routers have the routes for other WAN edges, which means it will help you in the fabric discovery. It will take care of your control plane activities basically. It will distribute the data plane and application aware routing policies to the vManage device. All the policies distribution is also done by the control plane, which is your vSmart device. It implement the control plane policies. So with the help of basically this vSmart device, what it has reduced the complexity of your control plane, because in your traditional WAN environment, we have these problems, right? This problem is completely solved and highly resilient, which means we have to go with the deployment of these devices in a cluster basically. We always go with the cluster deployment for your vSmart devices. This is all about your vSmart device, guys. Now, there's a one more device is left. Let me just go with that. And that device is everyone know is known as your orchestration plane, which is also known as vBond device, guys. So what vBond will take care of? It will take care of the orchestration plane activities basically. You have a vBond here. Now guys, let me just tell you one thing. If you are using Viptela edge device, the virtual appliance, which means that image is the same image for vBond. So vBond and your V is image of your virtual appliance is similar, guys. We can use same image for the vBond. Why we use vBond? We will use vBond for the authentication purpose. What do you mean by the authentication purpose, guys? Whenever your vanish devices, these devices, they came online. When they came online, what they will do first? To join your fabric, what they will do? They will always communicate with the vBond device first. They will communicate with the vBond and they will basically present the serial number. They will present the chassis number, because every device have a serial number and chassis number, right? When you will purchase the devices, you will get the serial number and chassis number. They will present the serial number and chassis number and the certificate. And they will communicate to the vBond. Now, what vBond have? So in this vBond, what we have the details of all your vanish devices. Whenever you will purchase any device from Cisco, right? You can able to see all these devices information into the Cisco support portal, right? With the serial number and all. So all this information, what we have to upload into the vBond device, which means your vBond have list of all the vanish device. If you have a 10,000 vanish devices here, which means it has a details of 10,000 devices. It has the serial number and chassis number as well. So when they will send the chassis number, serial number, what this device will do? It will authenticate them. It will whitelist them. And what it will do? It will also provide two things. It will provide the IP address, or we can say information of your vManager, and it will provide the information of your vSmart to these devices. How these devices they will communicate with vBond? They will use the DTLS connection. Now, who will basically configure the vBond information on these devices? So we can do it manually. Otherwise, Cisco have some solution is known as JetTP and plug and play. So I will discuss regarding this solution and some different class, guys, how this JetTP or plug and play works. And always remember, guys, one thing. This particular controller should have a public IP address. Means this controller is publicly reachable, because let's suppose these vanish devices, they want to communicate through the internet. How they will able to reach till this vBond? So that vBond should have a public IP address basically. If in the organization where your vBond is behind some router and all, you don't, in that case, what you can configure the one-to-one net as well. Means you can configure the one-to-one net as well. So if you will see here, it is a first point of contact basically. All your vanish devices, when they wants to join the fabric, they will basically contact with the vBond, and they will basically authenticate themselves with the vBond. And after that vBond, it will distribute the list of vSmart or vManage to all the vanish devices who just got authenticated. Means it will give the IP address of your vSmart and vManagers. And also it will inform to your vManager and vSmart, this is the device which is successfully authenticated. Now you may receive a connection, or you may receive a DTLS connection request from that device. It will inform to these devices as well. It is highly resilient, which means for the high availability purpose, we always go with the at least 2 vBond or 3 vBond deployment. So if one device is failed, we have another device who can do the who will take care of that vNAS traffic or vNAS authentication. We can also deploy on a multi-tenant or a single tenant mode, this vBond controller, guys. So this is all about your vBond control. Let me just see. I have also written some extra point here on my notepad. So let me also go through with that. So it offers the orchestration plane, which means it is also known as a security plane. So it will take care of the orchestration plane functionality, means it will take care of the authentication of your vNAS routers. It's a virtual appliance. We can spin this particular VM of vBond on AWS, Azure, Cisco, EXI environment, basically. It authenticates vEdge devices using the certificate serial number, or I can say here, let me add here chassis number as well. And it will whitelist them after that. Here mutual authentication so guys, also there's one more thing to remember. There is a mutual authentication is also happens between vManage, vSmart and vBond, guys. They will also authenticate each other, guys. It is responsible for distribution of vManage and vSmart information to your vNAS devices. It has to be publicly reachable, means it will have a public IP address. If it is not having the public IP address, in that case we have to do the one-to-one net, or we can go with the static net. If we want IP address is a private IP address, which means, let's suppose this is my vBond. If I have a private IP address here, what I can do the one-to-one net on this particular router. Okay. vBond and vEdge use the same software operating system or same OS image. It is the first point of contact or authentication will take care. It will authenticate all the vNAS devices. It facilitates the net traverser, guys. What's that? I'm just give you brief about it. So let's suppose this particular vNAS. Let's suppose this vNAS having the private IP address. And this is my firewall. Here I have configured the port address translation. Means right now my vNAS device is behind the net device. Behind the net device. If I have this, so which means how my, now it's a job of vBond. What it will do, it will detect these vNAS devices. They are publicly reachable, or they are basically behind some kind of net device. This is the job of your vBond controller, guys. Okay. It will take care of the net traverser things. It supports clustering and high availability. It can be deployed in multi-tenant or single tenant mode. So this is, guys, all about your controllers of your SD-WAN. Now, let's discuss the hosting of these particular controllers, where we can deploy. What are the deployment options we are having for these controllers? So all controllers we can deploy on cloud and on premises. So we have both options here. Cloud deployment can significantly improve the overall availability and redundancy of your management plane and control plane. Why? If you will deploy these controllers on the cloud and you want to scale up the resources, you can able to do it easily. So that kind of benefits you will get. You can consume the management and control plane as a infrastructure as a service, or even you can also get the software as a service. So both IaaS and SaaS, both options is available. If you want to utilize them, you can utilize both the options. People is basically preferred this particular option, SaaS, software as a service. In on-prem deployment, we need to take care of the rack space, power, cooling, physical servers, hypervisor, and your virtual machine and containers, right? All these kind of activities, we have to do it by ourselves. And we also need to take care of the redundancy and backup if we will deploy these controllers in on-prem. In on-prem, we can deploy either using EXI server or which is a vSphere, and we can use the KVM as well. In cloud, we have a AWS, Microsoft Azure, GCP, Cisco controller as a service. So these are the cloud options we have. Cisco offers the following options to the customer. Cisco hosted cloud. So your 90% customer uses the Cisco hosted controllers basically. And Cisco take cares of the provisioning all controllers. They handle the backup and disaster recovery of these controllers if anything happens. In this, customer are going with the software as a service by using the vManage to create the custom configuration templates for their devices and administrator the overlay fabric basically. So you can go with the software as a service as well, where Cisco will do everything for you. They will basically create the configuration for your sites. They will manage. If you go with the infrastructure as a service, they will give you the controllers. Now you have to write the policies, you have to do the configuration, everything by yourself. Now guys, if I'll give you the example, so like this Viptela company, it is started by the 3 peoples. They are from the Pakistan, and after few years they have worked, these 3 people they have worked together, and after that what they have involved 2 more people from India, and they have basically created this Viptela company. And what Cisco have basically acquired this company, and Cisco have basically what they have done, Cisco have changed the previously that solution is known as a Viptela SD-WAN solution. Now it is a Cisco SD-WAN solution. So we have a Viptela SD-WAN solution, then Cisco acquired Viptela, so it's become Cisco Viptela SD-WAN. Now it is totally a Cisco SD-WAN solution. You in your Viptela, you have a dedicated physical WAN routers of Viptela. Okay, and you do have a Cisco routers as well, guys. So we have discussed the management plane, data plane. We have discussed your management plane, control plane, and orchestration plane. Now let me just quickly discuss your data plane as well, guys. So in your data plane, basically your vManage devices come. These devices, this is your data plane. So if I'll go down here, now if I'll say these devices, basically, come on, let me just decrease the size here. I hope this image is visible, right? Cool. So if you will see these devices, basically, these devices comes under the data plane. Now here, what type of devices you will see? You will see the vEdge devices, which is known as Viptela vEdge devices, and you will see the cEdge devices, which is known as Cisco vEdge devices, basically. So in your data plane, we have a vEdge routers. They provide the secure data plane with the remote vEdge router. So guys, what they will do, your IPsec tunnels build between these particular vEdge devices, your IPsec tunnel build between them and your all the traffic of users which is behind these routers is go through this particular IPsec tunnel. With your all your vEdge devices, whatever connection they will make with your vManage, vBond or vSmart, this connection is your DTLS connection or TLS connection. Whatever connection they will make, your vManage device will make with another vManage, it is your IPsec tunnel or your IPsec connection. Establish the secure control plane with vSmart controller. with the help of OMP, enforce policy for the data plane and apply aware routing. So all these policies we will configure onto these devices basically. They will export the performance statistics to your vManage via SNMP protocol. They will leverage the traditional routing protocol like OSPF, BGP, and VRRP. These type of protocols we can run on these devices. They support zero-touch provisioning, and they are available on both the physical form factor and virtual form factor. Your virtual devices, guys, they just provide you the 10 Mbps of throughput. And if you need a higher throughput, you always go with the physical devices, guys, here. Now, if I'll explain you the list of physical devices, in your vanish, we have a VS100. This is the series. VS1000 series, VS2000 series, VS5000 series, and we have a VS cloud. And that cloud we will use. This is a virtual image basically. Then we have a CEs. In CEs, it is running your iOS XE and SD-WAN code basically. We have a ISR series routers, ISR 11 series, and ISR 4000 series. They are the CEs routers. We have a ASR 1000 series, and now we have a CAT 8K routers as well, and we have a CSR 1000V as well. So these are the Cisco vanish devices basically. So we can use ISR, ASR, CAT 8K, and your CSR devices. That's about your data plane. If you want, you can see the details here. Vanish routers, they are handling the user's data, so they comes under data plane. They are having both virtual and physical images. Virtual we use only for lab purpose or testing purpose because its throughput is very less. In production, we always use the physical appliances. They provide the secure data plane connection with the remote vanish routers. We can configure the traditional routing protocol like OSPF, BGP. So guys, just remember here we have one hack. Your OSPF and BGP is supported by the vanish routers only. If I'll say EIGRP, your EIGRP, BGP and OSPF is supported by your CEdge routers. So because EIGRP was a Cisco proprietary protocols, and they have not added that particular EIGRP functionality on your Viptela edge devices still. Okay. Vanish routers communicate securely with vSmart using OMP protocol to set up the data flow. Implements the data plane and application aware routing policies. They support traditional routing protocols, and they support JET-TP and PMP, guys. So this is the thing which I want to cover, guys, with regards to today's lecture. Now, these things we will see in your next class, or this I will start from hosting, because in hosting also I have to tell lots of other options, guys. Okay, so maybe we will see in your next class.